All right, so the correct answer, just to jump to the end on this, is K. All right. Now, it's a little bit weird seeing these two terms. I'm going to put 216x and 180x right here. And then on the side, I'm going to keep track of what my greatest common factor is. All right, so I can see that both these have an x. So this is technically 216 times x and 180 times x. So this x can actually be drawn out from both. So I already have x as a common factor. So let me go ahead and start with that. So 216 and 180 are left over. And x is going to be one of the factors. So I'm going to rule out f and g right now. Now, for the next part, because I know it's x, and I can already be certain that x itself is not the answer because these are both even. So I know that 2 at the very least is a common factor between those two numbers. So if you're following that logic, since I know these already have at least another factor that's common between them, I'm going to rule out x as well. So the question is it 12x or is it 36x? This is a multiple choice question. So you can try both of those. And when I say try them, I mean this. Divide both of these by 12. Do you get an answer? So in this case, if I do 216 divided by 12, I get 18. If I do 180 divided by 12, I get 15. So essentially, I pulled 12 out of both of these. And maybe it's easier to look at it this way. This is now 12 times 18 and 12 times 15. That's the same as the numbers we saw above. So I'm going to pull the 12 out from both. So I get 12x as a factor. So 12x times 18 and 12x times 15. But I can also try 36x. And from here, if I didn't have multiple choice and I was still trying to keep going, well, maybe what I could see is that 18 and 15 have a common factor. And what is the common factor between those two? Say that again. 3. So I can rewrite this as 3 times 6 and 3 times 5. And at this point, I'm going to pull a 3 out from both of those. So I'm going to have 3 times 12x. And of course, when I take 3 times 12, I get 36. I'm running out of space. I'm just going to try to squeeze this in at the bottom. So 36x. And what's left over is 6 and 5. There's no other common factor between 6 and 5. So I am going to call that good. So 36x is the biggest factor that's common between both of those that I can pull out. But again, because it's multiple choice, they give you 2 options to pick from. So you can try both of those and see if you can get a whole number for each one. But that is not necessarily the simplest, or that's not the most straightforward way, perhaps, of going through that problem. But it is essentially what we're doing. We're finding factors that are common between them until we find the very last one that there is no common factor between 6 and 5. Okay. Hopefully that made more sense than not. Today we're going to be looking at difference of squares. And this sounds a little weird. It's a special case of, it's a special case of quadratics. So let's look at this real quick. Here's an example of what this might look like. I'll say from the beginning, you're going to always know if it's a difference of squares, one of these special cases, if there's only 2 numbers here. But we're going to go through this one the long way the first time around, and then we're going to see that there's a trick for these. So the long way of doing this is by doing the full big X. I've got A, B, and C. And it doesn't look like right now I have enough information to plug in, but what I'm going to do is I'm going to expand this a little bit. And when I expand this, I'm going to have x squared minus 9. And normally we'd have something x in the middle. Since there's nothing there, I'm going to say this is plus 0x. So at this point, we have our 3 numbers. My A value is 1, my B value is 0, actually, and my C value is -9. And it's good to do the big X just to get another example, a little bit more review of it. So I've got A times C at the top, B at the bottom, multiply down here. Oops, that was backwards. Multiply at the top, add down here. So A times C is going to be -9 and B is 0. So let's come up with the factors of 9. What do we have? 1 and 9 and 3 and 3. So we could probably look at this and figure out how can I get a set of factors that will multiply to give me -9 and add to give me 0.
Make one factor negative.
Which two are we going to pick and which one will be negative?
3 and 3, and then one of the 3 is negative.
Yeah, it doesn't really matter which one's a negative here. But there we go. Now if I add 3 and -3, I get 0. If I multiply 3 and -3, I get -9. So let's just continue through. I know we have a shortcut for this. But let's go ahead and expand this out. So my next step is going to be x squared. This gets divided into plus 3x minus 3x minus 9. And from here, I can set up my Punnett square. All right. So for the first column, what's a common factor?
Yeah.
X. For the second column, what's a common factor?
3.
3. For the first row, what's a common factor?
X.
X. And then for the second row, we have
-3.
-3. There it is. All right. So now we've got our two factors, x plus 3 and x minus 3. So that's the long, full version of how we get our factors. And it's good that we went through that, like I said before, but now let's look at our shortcut. So one thing you might have noticed, maybe you didn't, but 9 is a perfect square. That will be a pattern that you're going to see with this. And x squared, we don't necessarily think of it as a perfect square, but whatever x is, it doesn't matter the number. X squared is a perfect square because it's that number times itself. So what we have is, of course, subtraction in the middle. So this is a difference of squares. That's what we're referring to when we talk about that. And when that's the case, I'm going to go ahead and clear this entire screen. And I encourage you guys to have some scratch paper to kind of copy down some examples. This is not going to be super complicated, at least compared to the full process. But you do want to have some examples so that you can understand what we're doing here. I'm going to clear everything. And this is my trick for finding the difference of squares. I want to take the first term, in this case is x squared. I want to take the square root of it. Well, the square root of x squared is just x. And I want to put that first for each of my factors. And then I want to take the second number. I'm not worried about the negative in this case. I want to take the second number and take the square root of that. So the square root of 9 is 3. I want to put that second for each factor. And then from there, I just need a positive and a negative. It doesn't matter the order. I could put the subtraction first. I could put the addition first. And what happens here, just to explain why this works, I know we just did the full process, but just to see it one more time, when I multiply, of course, I distribute and I would get x squared, but then when I do this, when I get my, so I'll go ahead and write the x squared. When I get the minus 3x, and then I get the positive 3x, and I'll just do this last one, -9. Notice right here that the -3 and the +3 will cancel each other out. That's why we need to have the negative and the positive. All right, so that's kind of just seeing it going back the other direction, why it works out that way. So there's our shortcut. And there's really not much more to it than that. But it does get a little bit more, let's just say there's a little bit more nuance to it. And we'll see some other examples in a minute. But let me have you guys see if you can just fill this one in. There's your two factors. Feel free to write on the screen what our factors will be as a result. All right. And you might or might not have worked through it and got the answer as fast. That is correct. Let's give you a second to think through it before I talk about it. Okay, so the first term is x squared, so the square root of x squared is x. You don't have to write this that I'm showing right now, but I just want to kind of make it really clear. That's why that x goes first for each factor. The second number is 16. Square root of 16 is 4. So that goes second for each factor. And then you need a plus and a minus in whichever order you want. So we're going to look at some problems that add a little bit of nuance to this. But before we do, I wanted to look at this problem. And this one is very, very tricky in the sense that it's incredibly tempting to come up with this. You say, well, there's a shortcut for x squared minus 25. So I'm going to guess that my shortcut here is x plus 5, x plus 5. And this is what a lot of people will assume. And I just wanted to show you real quick why this is not the correct answer. So be aware there is no shortcut for addition. I'm going to say that at the beginning, I'll say it in the middle, and say it at the end. So I'm going to go ahead and distribute this. So I get x squared plus 5x. I'm going to do the same with the 5. I'm going to get 5x plus 25. Notice what happens is these two terms actually combine and double. So I get x squared plus 10x plus 25. Well, we started with this. So we got this extra 10x. So the point is x plus 5 times x plus 5 is not the factorization of that. It does not work. So just put a big X through that. All right. And what's tricky about these, and I'm not going to give you problems like this because this, we can't even solve it with our normal big X method. So we would call this non-factorable. And you will learn methods for doing that in Algebra 2, which let's just say for right now, that's good enough. We're not going to worry about questions like that. So in case you were wondering if there was another trick, no, there's really not. It's just good for stuff like this, but this one adds a little bit of change. I'm going to see if you guys can go ahead and find the factors of this one. Okay, this one is a bit tricky, and this is tricky because this is not the order we expected it in. We expected x squared minus 36, but we got 36 minus x squared. And the process for our shortcut is actually to take the first term, whatever it happens to be, take the square root of it, which is 6. So that part's right. And we put that first. And then we take the second one. In this case, it's x squared. And the square root of that is x. I'm going to put that second. And then I just put a plus and a minus. So this is the correct factorization. And this one is tempting, and this is what a lot of people are going to want to do. But this actually is incorrect. And the problem is with this factor right here. So x plus 6, 6 plus x doesn't matter. This has what's called the communicative property. And going back to Algebra 1. And that says that basically x plus 6 is the same as 6 plus x. But subtraction is non-communicative. And what I mean when I say that is that x minus 6 does not equal 6 minus x. And we can just see that with 1 and 2. 1 minus 2 is different than 2 minus 1. They are not equal. So we can't just flip these two and call it the same. So maybe that's my long way of saying that this one at the bottom is a correct factorization. This is actually incorrect. So always just take whatever's first and get the square root of that and put that in first. And then whatever's second goes in second. So if that makes sense, I've got one more example that we're going to go through. Are there any questions on this? Clear this. One more example right here. So knowing everything that we've learned so far, another one, this is about as complicated as your problems will get, but I want you guys to look at that and see if you can come up with the correct factors for that difference of squares. So with this problem, we are looking at a difference of squares. And let me go ahead and tell you, I'm not going to trick you guys by putting a non-square in this. And just to say this again, you're going to know if it's a difference of squares if you only see two terms. With everything else, of course, you're used to seeing like x squared plus 8x plus 7. So you're used to seeing three terms. And if that's the case, it's big X all the way. But if you see just two terms, then that should be your cue right away. Okay, I think I can use the shortcut on this. And we take the first term and square root of 81. Maybe you know it. Maybe you plug it into your calculator and you find it's 9. So there you go. 9 went in first right here. That's good. Okay, the next term is 16x squared. So I'm going to take the square root of 16x squared. And this might be where some of you were getting held up a bit. But I want to kind of split this up. I'm going to turn this into square root of 16 times the square root of x squared, because that's an acceptable thing to do. We did that with our radicals earlier. And I can find the square root of 16 is just 4. And the square root of x squared is just x. So that's how we can come up with the 4x that got plugged in right here. Once we've got those numbers plugged in, then it's just add your plus and your minus. And notice here the minus went in first. That doesn't make a difference. So this, in the end, is our final factorization. And it's kind of nice to know that if you do see a problem like this, that no matter how complicated it looks, it's actually going to probably be a little bit faster to do than your regular factoring quadratics. And this is still a quadratic because notice it's an x squared. It's just a weird looking one. Okay, so with this, let me go ahead and clear. And you do have a new factoring quadratics 3 on Delta Math. Let me just show you real quick what that looks like. It's going to be a difference of perfect, well, they say difference of perfect squares here. And you'll see examples. And this is one that was very similar to what we just did. So if you know exactly what to do, you can, of course, just do the factorization real quick and come up with your answer. If you ever forget what to do, if you come across a problem, you're like, oh no, I forgot exactly what I'm supposed to do here. You know, just put in some stupid answer. That's obviously not right. And look here, it's going to tell you for the first term, and it says square root of the first term is just 10. Square root of the second term is 3x. So I'm going to get 10 plus 3x, 10 minus 3x. And I bet some of you were doing that in your head right away and already knew what the answer was. So with this, there's a good chance these will not take you very long. I think I assigned 10 problems. So I bet some of you could finish this in less than 10 minutes. So you guys have the rest of the class period to work on this. If you need to see more examples, let me know, stick around. But if you are good to go, you can sign off and I will see you tomorrow. Have a good day.